Hello everyone. Today we're very excited to share our project titled Energy Efficient Fine Tuning of Large Language Models on Devanagari script based languages. My name is Arsh Desai and I am joined by my colleagues Ashish Gedejala, NVJK Karthik, Priyesh Gupta, and Vinayak. We're all from Triple IT Dharwad and together we've been working on enhancing NLP with a focus on Devanagari script languages, particularly Hindi and Sanskrit, using the quantized low rank adapter technique or the QLoRa technique. So our project focuses on fine-tuning the Llama 2 language model for Devanagari script languages. This Llama 2 model is a very powerful language model and it has lacked coverage for the Devanagari languages, and that is exactly where our project comes in. We've integrated the QLoRa technique to make this fine-tuning process not only effective but also energy efficient. Now imagine a synergy between Llama 2 and the intricate Devanagari script and the efficiency of QLoRa, and that is what we are aiming to achieve. The challenges of adapting Llama 2 for Devanagari script languages are that there is a lack of linguistic resources when compared to the well-established adaptations for English language. So our motivation lies in overcoming these challenges with a focus on resource efficiency. We want to make language processing accessible, especially in resource constrained environments and settings. So introducing this QLoRa technique is a game changer. It will allow us to achieve efficient fine tuning and reduce the demand for extensive computational power. Our literature review has identified the following research gaps within the existing hybrid approaches. So these approaches, they often have a lack or of a specific focus on the Devanagari script, and additionally these studies highlight the need for systematic inclusion of related languages to improve the downstream tasks, which is crucial for Devanagari NLP. The introduction of QLoRa addresses the resource intensive nature of Llama 2 fine tuning, and it will fill a gap in the existing literature.
Now let's delve into a crucial aspect of our project, combining datasets for fine-tuning Llama 2 on Devanagari script-based languages. The strength of our model lies in the diversity and richness of the training data. Linguistic diversity is a cornerstone in our approach, ensuring the model's adaptability to various language nuances. Hindi chat dataset. This dataset is a linguistic treasure trove encompassing conversations in English, Hindi, and Sanskrit. It provides a real world linguistic context, allowing our model to understand and generate text in a conversational setting. Bhagavad Gita verse wise, for a spiritual touch, we have incorporated the Bhagavad Gita verse wise dataset available on the Hugging Face hub. Hindi Wikipedia articles that are 55,000. This extensive dataset comprising 55,000 Hindi Wikipedia articles is a valuable resource. In our quest to enhance the efficiency of our language model, we turn to PEFT, parameter efficient fine tuning. Prefix tuning, P tuning, and LoRa are key players. LoRa specifically stands out for its wide adoption due to its effectiveness in reducing model parameters. LoRa variants has like QLoRa and long LoRa. Here is a more detailed explanation of how it works. LoRa works by breaking down the weight update matrix into smaller matrices and using them to train the model. Take a look at the diagram above. The delta W A cross B is the weight update matrix. The matrix of learned changes from backpropagation. This is the same size as the number of parameters we need to update to fine tune our model. This matrix or any matrix can be represented as a set of smaller matrices presented here as A and B and with R as their rank. The R parameter controls the size of the smaller matrices. These smaller matrices can then be used to train the model using normal backpropagation, but updating the parameters in the smaller matrices rather than updating directly in the model. We basically learn the delta W through the smaller matrices. These smaller matrices can then be multiplied together to get back the original matrix. As these matrices are much smaller, this process uses fewer parameters and as a result, much fewer computation resources. These also results in smaller checkpoints as you don't have to store the whole model but just the smaller matrices.
Let's talk about QLoRa. QLoRa is short form for quantized low rank adapters. QLoRa works by introducing three new concepts that help to reduce memory while keeping the same quality performance. These are 4-bit normal float, double quantization, and paged optimizers. Let's talk about these three very important concepts in detail. 4-bit normal float or NF, 4NF, is a new information theoretically optimal data type built on top of quantile quantization techniques. Double quantization is the process of quantizing the quantization constants used during the quantization process in the 4-bit NF quantizations. So as you can see in this figure, in full fine tuning, we are using just one base model and fine tuning it. In the LoRa, we are using separate adapters of 16-bit. But in QLoRa, we are using the 4-bit normal float quantization. That's why there is a 4-bit transformer as a base model, and we are quantizing each adapter individually and combining it. With this, you can see the data is also not linear but separated in quantiles. As you can see, here are all the parameters and the trainer procedure using QLoRa. You can find more details in the code we will provide in our GitHub repository. You can even run and find inferences for our Llama 2 model. Here, LoRa attention dimension is set to 64, which means it has the ability to focus on for longer tokens, which is what we are trying to achieve for our large language models like Llama 2. And as for the training procedure, you can see we have set batch size as 4. Standard is usually 8. However, to put less load on our GPU, we are going to compromise with a longer training time for the LLM. This can be achieved with better GPUs. We are using paged optimizers for optimization. This is one of the special features that we talked for QLoRa.
Now let's look at the results. In this input, we are asking the model, "आपका नाम क्या है? आप कैसे हो?" And the model is giving the output in English. So we showcase the versatility of our model by presenting random Hindi text in the Roman script and Devanagari both. The model dynamically interprets and provides meaning of each sentence, demonstrating its proficiency in understanding and generating Hindi text. In this input, we are asking the model, "मुझे गायत्री मंत्र लिख के दो." Then the model presents the sacred Gayatri mantra, a significantly and widely recited verse in Hinduism. Our model accurately transcribes the mantra in Devanagari script, preserving its spiritual essence. Now, in this input, we can see that we are able to transliterate an article which is purely written in English language into Hindi, although some workaround is required when inferencing. Now, to exemplify the practical application of our model, we delve into a news snippet related to Narendra Modi. Our model is not only translating the news content into Hindi but also extracts and provides the meaning, showcasing its capability to process real world information and offer valuable insights into the news context. This section underscores the adaptability of our model for tasks beyond conventional language translation. Now we'll look at the BLUE score, that is bilingual evaluation understudy, is a metric for automatically evaluating machine translated text. The BLUE score is a number between 0 and 1 that measures the similarity of machine translated text to a high quality reference translation. We evaluated our model using BLUE score, a standard metric for translation quality. The baseline Llama 2 achieved a BLUE score of 5.20, and after fine-tuning we significantly improved language understanding, achieving a BLUE score of 34.87. We'll now also compare our results with ChatGPT 3.5 Turbo, highlighting the versatility of our model across various Devanagari languages.
Now, let's look into the pros and cons. The pros. Groundbreaking adaptation. Our Llama 2 model is a groundbreaking adaptation for Devanagari, enhancing accessibility. Robust linguistic proficiency. The model excels at precise translations and understands complex language structures. Open source tools. Llama 2 is affordable, open source, and supports multiple languages, democratizing language processing as well. Cons. Resource demands. Fine-tuning requires a 16 GB VRAM setup, limiting accessibility for users with less powerful hardware. Learning curve. Users unfamiliar with Llama 2 may face challenges requiring training and support. Dataset challenges. Integration relies on diverse datasets, potentially impacting performance due to variations in quality and uniformity. In essence, our project represents a groundbreaking adaptation of Llama 2 tailored for Devanagari languages. Leveraging a breakthrough with a minimal 16 GB VRAM setup, we enhance accessibility, emphasizing a core focus on robust linguistic proficiency and innovation. These efforts significantly contribute to advancing Devanagari understanding and democratizing language processing. Our project is set for continuous growth, exploring enhanced linguistic diversity through ongoing research and advanced fine-tuning techniques. We welcome collaboration from the research and development community. Moving beyond research, we aim to integrate our model into real-world application focusing on Devanagari languages. So as you can see, these are the references that we have used. We have used the reference for QLoRa from GitHub and picked our datasets from Kaggle and Hugging Face. We have also attached the link to our GitHub repository where you can access our code and also see how to run it. We would like to extend our sincere thanks to Dr. Animesh Chaturvedi, instructor for DS303, Algorithms for Artificial Intelligence, for his invaluable guidance. His expertise shaped our research and we appreciate his dedication to our academic growth. I would also like to thank you for providing us with this opportunity to present our work. Thank you.